Hi, I'm here to talk about the Lab 16 setup. Lab 16 is the delta H of vaporization and the delta H of fusion of water lab. And this lab has two parts. In the first part, we're taking volume and temperature data for water vapor to find out the delta H of vaporization. And in part two, we're taking mass and temperature change data of water and ice to find the delta H of fusion of water. And I want to talk about the setups for those kind of one at a time. So this is the general setup for part one. What you can see here is I have a ring stand across the top and down the side here. This that you can only see a little bit of is a hot plate. So this would be how I can heat something up. And on the hot plate, I have a beaker and a graduated cylinder and a thermometer. Now it's filled with water. So before I filled it with water, they looked like this. This was the beaker, it's called a tall boy beaker. And this is the graduated cylinder. It's one of our 10 mil graduated cylinders. It's just on a wire so that I can suspend it in the beaker. And what I did is I filled my beaker with water, and you can see the water there on the surface. And then I put the graduated cylinder upside down into that water. But when I did that, I made sure that I trapped a little bit of air and that the rest of the graduated cylinder got filled with water. So you can actually see on this picture, right about there, that's filled with gas. And then the rest of this graduated cylinder is filled with water. Now that gas that's trapped in there is mostly air, but there's also some water vapor. And that's the part that we're interested in. So what we would do is we would heat up this hot plate. The hot plate would heat up the water in this beaker, and that water would heat up the gas in that graduated cylinder. And as the gas heats up, it's going to expand, and we would make volume measurements as we measured the temperature also. So we would get a set of volume measurements and temperature measurements. Using that information, we can make a graph, and we can use that graph to find the delta H of vaporization for water, which is how much energy it takes to boil water. All right, so that would be the setup for part one. For part two, we're trying to find the delta H of fusion for water, which is how much energy it takes to melt ice. And to do that, we would use our fancy calorimeters. So that's just two coffee cups nestled with each other here, and then a fancy lid. The lid has a hole in it so that you can put a thermometer down through that. And what we would do is we would take the mass of this calorimeter, we would put some water in, some warm water, and we would take the mass again, so we would know the mass of the warm water. And then we would put a thermometer down through the top, and we'd find the temperature of that warm water. Then we would add some ice to this, and we would take the temperature after the ice had melted. So the temperature is going to go down, and we would get that temperature. Then we would take the mass again so that we could find the mass of the ice that we had added to our warm water here. So using those mass and temperature change data points, we can calculate how much energy it takes to melt the ice that we used. And that's the delta H of fusion. So that's the setup for part one and part two of Lab 16.